morning, everyone. I am Aishwarya Reddy, working as a lecturer in RIT Polytechnic College, Lohegaon, Pune. A very warm welcome to all the distinguished speakers, faculty members, and participants. It gives me immense pleasure to welcome you all to the Faculty Development Program on Artificial Intelligence and Machine Learning, organized to enrich our knowledge and enhance our understanding of the emerging trends in AI and ML technologies. Now, I proceed by highlighting today's agenda and providing a brief introduction to our distinguished guest speaker, Professor Rahul Borate sir. It is my pleasure to introduce Professor Rahul Borate sir, an accomplished academician with over 13 years of teaching experience in the field of quantum technologies, artificial intelligence, data science, and machine learning. He is currently an assistant professor at K.H.Munde College of Engineering and Management, Pune, and is pursuing a PG diploma in quantum technologies from MNIT Jaipur along with PhD. Professor Borate sir has contributed extensively to academic and research initiatives including IIT Bombay's FOSSEE project and National Quantum Mission. He has authored over 5 books, published research papers in reputed international journals, and has been recognized with the Outstanding Contribution Award from IIT Bombay. His expertise spans quantum computing, Python programming, QuizKit, and machine learning, and he continues to inspire learners through his commitment to innovation and excellence in education. Now it's time to begin our faculty development program. We are truly honored to have with our distinguished speaker, Professor Rahul Borate sir, who will be delivering the session on exploratory data analytics, data collection, data cleaning, and data pre-processing. Sir, we request you kindly commence today's FDP session and share your valuable insights with us.
Hello, am I audible?
Yes, sir.
Yes, sir.
Vinod sir, actually mobile, okay, mobile but issue with laptop.
Sir. Yes, sir.
There is no issue with the mobile, but
Huh.
the laptop I am using the college internet, so maybe firewall settings will be there. Actually, Google Meet will be banned by the college firewall.
Okay. Can you connect your laptop with your mobile?
Yes, sir, but I think so. Speed of the internet. I will
Okay.
check, sir. We will try with the mobile net, right?
Okay, sir. Okay. You'll take time, sir.
Okay. Okay.
Participant remain present because the guest speaker will joining shortly. Having some technical issue.
तो मेरा 9 तारीख को एक्सपायर होना है सर। मतलब
All participants wait for 2 or 3 minutes. The session will be started because some technical issue occurred at the speaker sites. So wait for 5 minutes. Am I audible?
Yes, sir.
Okay. Okay. Okay.
Hello. Hello. Am I audible to all?
Yes, sir. Yes, sir. Yes,
Yes,
sir.
sir.
Audible, audible.
Okay, sir. Okay, sir. I'm just presenting my PPT.
Yes, sir. Your screen will be visible.
Okay, sir. Thank you, sir. Sorry for the
Okay.
delay. I'm joining from the
No,
lab now, actually.
no issue.
What
No
happened to
issue,
my
sir.
laptop card? I don't know. So we'll start now, right? Um,
Yes, sir. Yes, sir.
okay. Good morning to all, and welcome to this FDP update 2. Myself, Professor Rahul Borote. I think so. My introduction is already over. I have not gone through that sessions due to this technical glitch. So I'm from the K.H.Munde College of Engineering, Waguli, Pune. And our today's session is on the exploratory data analytics, data collections, data cleaning, and data pre-processing. So in EDA or exploratory data analysis, mainly we take the raw data and we do some processing, cleaning, and transformation of the data. And finally, we came to some conclusion, we came to some insights, and that insights is useful for our business purposes. So from all these transformations, data is gone through raw to some we just get some getting some diamonds from the coal mines. That concepts we apply here in EDA, exploratory data analytics. So why EDA on raw data? Why we have to do the EDA? See, nowadays data is not the new oil; it's the new soil. So days gone, people are saying that data is the new oil. But what happened with the oil? Oil we once extracted, refined, and eventually we use it. We cannot reuse the used oils, or we cannot regenerate the oils once we use it. But in case with the soil, we compare these things with the soil data. So in soil, what happens is for cultivating any crops, we gone through the some preparation of the soils, then we take care of the soils, we checking whether nutrients are present in our soils or not, and we again take care of the environments. Similarly, in our exploratory data process also, we are preparing the data, cleaning of the data, structuring of the data, structuring of the data. Again, we take some cares of the data, we use some pipelines, to transform the data, and finally we use some infrastructure tools and we get the final insights from the data. So nowadays data is new soils. It's depend on the person who handling the data to cultivate what type of the things, and these things mainly related to your business requirements, business needs. So on the basis of your business needs, your business domains, we cultivate the data and we apply some AI models on this data and we get the flourished results. We're taking simple example, recent example of this EDA process. See, simple example of Operation Singar is happened 4 to 5 months back, and one of the our Indian Army used the AI for the exploratory data analytics. We get the insights of enemy, where the bases are located, where their drones are located, and all these things. First, initially they do the exploratory data analysis, and on the basis of that exploratory data analysis, they hit the targets and result in front of you. So future wars or the tomorrow's war will be fought with the algorithms, autonomous systems, and AI. So these things will be used in war-like situations also. And for accomplish the result, we require the exploratory data analysis. We have to go through the proper EDA process, right? So this is the recent example of what EDA can accomplish. Then normally in exploratory data analysis, we have the 10 to 11 steps are there. In step 1, we have data analysis, then we gone through the data handling. In the data handling, we check for the data duplications, where missing values are present or not. Then we come to the exploratory visualization. Mainly within these exploratory visualizations, we check the features, we check the columns one by one. That is unitary analysis we done. Then we go to the bivariate analysis, then we go to the multivariate analysis, then we come to the some descriptive nature of the data, descriptive statistics nature of the data, then we transform the data, like we treat the missing values, we treat the outliers present within the data, then we create new features within our data, we reduce some features from our data, and then we convey the insights to the further process. So this is the typical process of exploratory data analysis. And in this process, exploratory data analysis, I'm not going depth on the theoretical aspects. My motto is to hands-on sessions on this exploratory data analysis. So for that process, I'm just taking the one tool. That tool is Jupyter Notebooks. And within this Jupyter Notebooks, we're taking one data set, car data sets, and we apply all these 10 to 11 steps on that particular use car data sets. I hope my Jupyter Notebook screen is visible to all.
Yes, sir.
Okay, sir. Then our first step is to collect the data. So in data collections also, there are many sources from where we can collect the data. Normally, we are taking the data from databases, then CSV files, APIs, and web scraping. These are the common sources of collection of the data. And once you collect this data, yes, ma'am.
Sir,
Yes, ma'am.
that Jupyter notebook is not visible to me, sir.
PPT is not visible.
Yes.
She is asking about the notebook.
Yeah, ma'am. I'm switching between the PPT and notebook. Don't worry, ma'am. I will show you the
Okay.
hands-on session also.
Okay,
Don't
sir.
worry,
Thank you.
ma'am. So in data collections, we normally understand the context of the data based on our problems. So what type of problems you want to address, and on the basis of that problem statements, we can address the features. We remove some features, we add some features within our data. Then specifically within this sessions, I'm using the used car data for the predicting the used car price. So for that, I required some. I taken the Kaggle data set and I download it already. Already I download it. If anybody interested for the interactive hands-on sessions, then tell me. I will share you the data set also. So in Jupyter notebooks, create one new notebook. Just give it the name FDP_EDA. I'm just increasing the font so that you can easily read whatever I am written here. Is it okay now?
Yes,
In
sir.
step one is collection of the data. Collection of the data, and for this data collections we require some libraries. That libraries we first import. So we require the pandas library, then we require the numpy library, then we require the some visualization libraries like matplotlib and the pyplot, cbans. So we initially import all these library. So import matplotlib. From the matplotlib we require the pyplot. Then we require the cban library. We are importing this cban also. Then we are importing the warning package so that any warning is there, it can be ignored. Ignore the warning. We just execute this cell. We imported all the libraries. Then again, one more thing we have to do here. We are just reading our data in data frame. So for that, we require the one function from the pandas library, that is read. Our data set is a CSV file. So we are taking the CSV functions to read that data, and then this we have to share the path of our folder where our data set is. and just copy paste this path. Then pasting here and name of our data set .csv, extension of the file. And here we have to pass the raw string so that they can forget the special character meaning like slash and space are there. So this can be forgot by using the raw strings, and we give the name here data. So within the data variables, I'm just importing the cars data set, and this data is nothing but it's a data frame. So we are ready read the data and checking the some initial insights of our data, like we are print some first 5 rows of our data. For that we require the head functions. The job of the head is to print the just reduce down the some size so that you can easily get all the features of our data sets, right? So this head functions tells us about our data. Initial 5 rows will be shown here, right? So these rows contains the it gives us the 5 rows where name is there, location is there, year is there, then there is a kilometer driven variable is there, fuel type is there, transmission type is there, owner type is there, mileage is there, then engine is there, power is there, seats, new price and price. So these are the features in our data sets. Then you can see some last 5 rows also. So for want to go through the last 5 rows, then you can use the tail functions. So tail functions tells us about the last 5 rows. Then after this, we just gone through the info functions, where info function told us about the what is the type of the data of that particular variables. Like here, serial number is of integer types, and again it gives us the null counts. How many null values are not null values are present within our that particular features. It can be shown through the info functions. So normally there are 13 features are there, starting from serial number to price, and each features like serial number is there is 0 null values, the name also there is 0 null values, and in some other features there are some null values. For getting the total number of null values, we have again some functions. Pandas library is null function is there, and once you apply the is null functions on the your data frames, it gives us the result in the form of T and F, true false boolean format. But suppose you want to add up all these null values, then you have to give dot sum functions in front of them, then it will calculate total number of null values present in your data set on each feature, right? So we are calculating the total number of null values present in each feature. For that we have to apply data dot is null. Again, suppose you are not remembering the names of this all this pandas library, then simply you can do here, came here, give the name of the data frame, then dot and press the tab. So this will show us the all the names, whatever name you want to, whatever methods you want to apply in your data on your data frames, that will be shown on here, right? So I require the is null, and suppose I'm not remember the name of is null, then I just type is here, so it will shows all the alternative. So is null is there, right? So is null is the method. Then sorry, is null dot sum. So this will shows us the total number of missing values present on in each feature. Like name, there is 0 total values. Location, there is 0 total values. Total null values present. Then here also 0 total null values present. Kilometer driven, fuel types, and transmissions up to owner type. There is no missing values present in our data set, in our feature. But in mileage, there are 2 missing values. Engine, there are 46 missing values. Then power feature, there are 46 missing values. Seats features also 53. Then new price is a large numbers where missing values are present. Then price also a large number, in large number the missing values are present, right? Then you can check with the percentage also. So percentage wise, each features contains the null values. How to calculate this? Simply divide it with the len functions, len of the data, calculate the length of the data, and multiply with the 100. So it will give us the missing values present in the form of percentage. If you look at the new price, where 86% missing values are present, it means there is no points to investigate the new price features. So better you can directly drop these features. See, there is a thumb rules. If suppose more than 50% null values are null or missing values are present in your features, then you can directly drop that features, because putting the or the replacing that null values with some values is there is no points, right? So here we can dropping the new price features, new price from our data sets. So for dropping these features, we require the drop functions, right? See, there are 2 features present in our dataset: serial number and the new price. There is no points to present these 2 features in our datasets. Instead of that, we directly drop these 2 features from our datasets. So for dropping these features, we require the drop functions. So data equal to data dot drop. Again, show the signature of these methods. Give the label name and axis equal to, see, axis equal to 0, it means we are dropping the rows, but here we are dropping the columns. So we have to mention here the axis equal to 1. By default is axis equal to 0, right? So our feature name is serial number and the we are dropping the serial number and the new price. So data dot drop, give the name of the features s dot, this is the feature name of my, and join the remaining columns with the help of x is equal to 1, right? So this will drop the serial number from our data sets. It shows us the not found in axis. Okay, in our column, I have to first check the serial number. Okay, there is no space. Okay. Yes, one dot is remaining. We have to take the proper care for giving the name of the features here. Then one more features we have to drop. That feature is new price. Again, the new price name is capital N underscore. Again, P is capital price, right? We have to pass this features in a single quotes, complete the bracket and join the remaining columns. X is equal to 1. So this will again drop the new price. Why we are dropping the new price? Because in new price almost there are 86% missing values are present. So there is no point to filling these missing values by other values. So again we are checking whether these features are drop or not by using the data.info. Yes, now check the serial number is removed and the new price also removed, right? Then next point is see there are very few column. Check name is our object data type, location is our object data type, year is our integer data type, then kilometer driven also integers, and seats and price are also integer data type. So by cleaning some features, we have to add some features also, create some features from the existing data sets. Then how to create these features? See, within the name, if I do the head here again, data.head, can just gone through the name features. There are brand and model name is includes within this name features. So, brand and model name is again added features. It can be directly correlate with our price column. So price is our targeted value of the label data. Then we just split this name with the brand and the model by creating the extra features. Then how to create the features? For creating the features, these comes under the feature engineering part, right? Again, we just give the name of the features equal to from the existing features. We split that data and we create the new features, right? So in our data set, there is a one more feature is there here, and we cannot get the direct insights from the year also. So while looking at the years, we are not going through the age of the cars. So we are creating the new features, car age from the year column or the year features. For doing that, we just import the date modules from the date time package. Import date from the date time Then we are creating the new features, and the name of that new feature is car age. So just taking the today's date from the date. So date dot today dot year. Year is important. So today is a 2025. From this date dot today dot years, we are extracting the 2025. From this minus the car's years. So in which date the car is built. So minus data within the our data frame name feature is year, that car year is mentioned, right? So we are just making the subtractions between the today's date and the car's existing years, right? And creating the new features car age. Import date time from date times import date. So it will import the date, and we can easily create the new features car age. So we can show these features also with the help of head functions. This newly created functions can be shown at the last C. Car underscore age is our new features, and it just calculates the car age. How many numbers of this car is old? It can be easily calculated with this car age. But while looking at the year only, there is a difficulty for fetching the years. How many years of that car is old, right? Then again, we are creating two new features, brand and the models, from our existing name variables. So we are creating the new variable brand from our existing feature date. So data dot, there is a variable name, and this name variable again is the object type. First we have to convert that object type into the string by using the str. Then on this string we can split that string with the help of split functions, and again after splitting the string, we're again assigning the each string with new features. Like in brand, for the brand we are assigning the or first string first splitted string, that is it contains 0, right? At the 0th place brand name is there, so just split that string into the string, and again fetching the brand name at the 0th positions. So at the 0th positions of the data name there is a brand names. Then one more features we are creating, that feature name is model. Again model name basically it present at the positions 1 and 2. We are just splitting the string or existing string of the name variable name. First initially convert this into the strings, apply the split function, and again at the first position there is a model name, So we are accessing that model name. Again, some model names are up 2 words also. So you can take the next word also. That is data dot name dot str. Then again split that. Split is a method we actually split the string, and here the string is splitted on the basis of this space. And again we are getting the splitted string at the second positions. So at the 0th positions we have the brand name. At the then first position and the second positions we have the model names. Execute this cell also, then check whether all these newly created features added in your dataset or not. So data of, give the name of the features, name. Again, all these features you have to put in a single quote, separated with the commas. Give the second name, brand, then separated with the commas, model. Right? And just look at this data. So we have created 2 new features from our existing features name, that is brand and the models. Like here, example row 0, Maruti Wagoner, right? So this is the name of our car, and we just separate out this name with the brand and the model. So brand is Maruti and model is Wagoner, because these 2 things will be contributed to our price. Whenever you are calculating the price of car, the brand and model are the key parameters. So we created these 2 parameters. Then again, look at the data.head or the data.info. We have to convert some object data into the numeric data. Like see here, mileage. Mileage here in the form of object. Again, engine also in the form of object. So whenever data is in the categorical form or in the object forms, that analysis of that data is somewhat complex or somewhat difficult. So for the bivariate analysis or the multivariate analysis, we required some numeric data. So that is normally in the form of numerics, like we normally say that my car is going through the 23 kilometers in within 1 liters, or engine is of 1500 cc, 1000 cc, 1200 cc. So these are the numeric numbers. But right now in our data set, these numbers comes in the form of object data, right? So our job is to fill the missing values of these features and convert that features into the numeric one, right? So first we converting the mileage into numeric with filling of the missing values. So mileage will be replaced with data. We are fetching first the features those want to replace with the, so replace features will be mileage from present within our data set. And again this features contain some missing values, right? And again this feature contains first part as a number value and the second part as a kilometer per hour. Just you can look here. If I give the insights of the data dot head. If you're looking at the mileage features, there is a first number is in the form of numeric, and second in the form of, again, it's a string. So this is object data, and our job is to convert this object data into numeric one. So when we converting this object data into string, it will be splitted into two strings. So zeroth string will be 26.6, that is a numeric one, and the at the position 1, this kilometers or kilometer per liters or kilometer per hours will be changed. So we are ignoring the second part. That string is not required to us. We are only focusing on this numeric parts. So we are just extracting this numeric part from our object data, right? So here we are just converting this feature first into the strings by applying the .str. So object features will be converted to the string. Then we split this string so that we can easily extract the numeric parts. So split, and again we are fetching these zeroth positions, right? Up to this, we have just converted the features into the strings. Then we fetch the first part, numeric part. But for doing this, we have to first replace the none values, because some none values present in our data sets as a string also, or in the form of dash also. That we have to replace with the 0, and then you can easily extract these features. So some may be dash, again some may be NaN, not a null. So this will be replaced with the 0. So before replacing, it will be converted to the float first. So as type float, then it can be filled with the help of fill NA functions. So this missing value will be filled with the 0, and again it can be converted to the integers. So as type int, as type, and you just give the type of that is the int, because we required these features in the form of numeric one. So just executing this cell, right? So mileage now converted into the numeric one. Then again, same like this, we have to convert the engine also. Look at the engine features. First part as a numeric, second part as CC as a string, but we require some only numeric data here. So you can easily convert this engine also into the numeric one. Initially it is an object type, but we want it in a numeric one, so that it will be contributed more for predicting the price of our car. So name of the engine is engine. So new feature will be created, data engine, from the existing feature engine, where we split this feature. First we convert it into the strings, then that string will be splitted into two parts. At 0th positions we have the numeric parts, so we extract that numeric parts, and if suppose any missing values are there, dash is there, the not null function is there, not null values are there, then that can be replaced with the zeros, and finally we converted it into the integers in the numeric ones, right? So these two features we created. Again, we can look into the info functions. So info functions tell us about the type of the data. See, we have converted mileage and the engine. Initially, it is an object type, but now it will be converted into the integer ones, numeric ones. Again, all the missing values are filled here, right? So collectively, this whole process is called as feature engineering. At some points, we are removing the features. At some points, we are adding the features. Then we go for the some data cleaning parts. Like in our data set, suppose there are some wrong entries are there, then that wrong entries will be replaced with the correct one. And for replacing that, first we have to check whether any wrong entry is present in our data set or not, right? Then how to check it? Just simply put here the data. Data is our data frame, data set. Then we are looking at the brand only, but within a brand there are some wrong entries are there. Check first data.head. Instead of data.head, I'm interested for the whole data sets. Then in the brand features, there are some wrong entries present. So that can be removed with the help of data cleaning part. So I'm interested for the brand data.brand dot unique values. Unique values present within this brand. Unique name present within this brand. See, these are the brand names: Maruti, Hyundai, Honda, Audi. Then likewise, we have the land, but there is no car with the name of land. There is a Land Rovers, right? So this is wrong entry. Again, there is a Mercedes-Benz there, BMW, Mahindra, Ford, Porsche, Datsun, Jaguar, Volvo, Chevrolet, then Skoda, Mini. See, here again the Mini, there is no Mini brand name present. So there is a Mini Cooper brand is there. So we have to replace this also with the proper name. Then there is a Isuzu. There are two entries present. So we have to replace these brand names with the unique one. Again, you want to check the how many number of unique brand name is present. Then simply we have put here the n unique functions. So it will give us the number, how many number of unique brand is there in our data sets. Data.brand and unique. Series object has no attributes and input it. Then enter. Check with the functions. Yes, there is an unique function is there. Then total 33 unique brand is present, and some of the brand names are incorrect that we have to correct, right? Then how to correct it? All these brands, simply replace the multiple entries with the single entry, like we are doing this here for the brand Isuzu. So data, first check features where you want to replace the brand name. Or you just simply put only single brand name. So replace the brand name with the help of replace functions. Just simply pass the dictionary here. What you want to replace. So I'm just interested to replace this capital entry with the title case. That is, first letter is capital and the remaining letters are same. And you just put here, replace the changes with the help of in place equal to true. So you can easily replace all the changes in your data set by simply putting the in place equal to true. Right? So we execute this and again check whether this reflection is happened in your data set or not. So data.brand give the unique function. So it will be replaced in your data set. See, there is no Isuzu entry present in 2 times. Only single entries are there. Likewise, you can replace the land with the Land Rovers and Mini with the Mini Coopers. Land with the Land Rover. And one more is Mini with the Mini Coopers. So these wrong entries we replace with the correct one. Now our data set is clean, somewhat clean. And again we check all the brand is replaced or not. See, now all the brand names will be replaced with the unique names. There is no wrong entries present with this brand name now, right? So this step is called as data cleaning part. Then after data cleaning, we are more interested for the exploratory analysis. And in exploratory analysis, before going to the exploratory analysis, we just gone through the some descriptive nature of the data. Then how to show this descriptive nature by using the describe functions. So this function will show us statistical meaning of the data. Like all these are the numeric features present here: kilometers, mileage, engine, seats, price, and the carriage. It gives us the counts of total, then mean value of each features, standard deviation of each features, then minimum value present within that features. Then it gives us the interquartile range and the max value present within that particular data sets. So this is the descriptive analysis of our data sets. If somebody is interested for the standard deviations, minimum value, count, mean, max, or interquartile range of the data sets, then they simply put the function data.describe and it will shows us all the numeric features, statistical inference values. Suppose you are interested for the categorical data also or the object data also, then we simply put here describe the within describe functions, we just include the all. So it will include the all features from your data set. It's small. Then you can go through again some categorical descriptive nature of the data also. Right. See, all these are the, this is the inclusive descriptive statistics, numeric and the categorical data also, object data also. So after doing the descriptive analysis, now we are ready to go for the univariate analysis. So mainly univariate analysis is nothing but we are checking each and every columns individually so that we can get some insights whether each feature is distributed equally, distributed normally, whether is any skew is present within that features or not. That parts you can easily figure out with the help of univariate analysis. But before going to the this univariate analysis, we have to list out the categorical columns and the numeric columns. Then how to list out all these categorical and the numeric columns? It's simply you have to list it out with the help of select D type functions. Yeah, I'm just interested for the numeric columns. So equal to, first select the features from the data frame, name is data. So there is a method select. So this select D types will include the column on the basis of their type. So include, just mention here the type of data, what type of data you want to include within your. So for the numeric one, you have to use the numpy functions np.numbers for selecting the columns from your data sets. Numbers, and just simply put here the columns and append it in a list, to list. So it will include, okay, include equal to, something is missing in the include, the types, include, data frame dot select got an keyword argument include. Yes, spelling is wrong. Include spelling is PLUD. Then print this num columns, numeric columns, right? So we list it out within single variable all the numeric columns like year, kilometers, then mileage, engine, seats, price, and the car age. Similarly, you can list it out the categorical variables in one variables. So cat calls use the same functions or the same code, data dot select, this is the function, and And include here we require the object data. So just simply put here the object dot columns. Whatever columns are present within this object, that will be find within this and show this categorical column. Right. So now we are ready for the univariate analysis. We combine the both numeric columns and the category columns within the different variables. So what is univariate analysis? See, in exploratory visualizations, three things comes. First one is univariate analysis, then second one is bivariate analysis, and the third one is multivariate analysis. For the univariate analysis, we check each and every columns one by once. And normally for the numerical data, we use the histograms to investigate the details present within that features. For the distributions and the box plots, will showing the outliers present within that features. Then in categorical columns, we use the bar plots and the scattered plot. So these two are the visualization techniques used for the showing the univariate analysis. We have just gone through the univariate analysis of our numeric columns. So we just loop through it. So for column in name of our numeric columns is num underscore calls. Then we create one figure here. So with the help of matplotlib plt, create the figure. So there is attribute figure here. Then extract it and give the two parameter here. First parameter is figure size. See, you want to show the significance of this figure, then there is a figure size attribute is there. So we are taking the figure size attributes, width and the height of the figures, what width and height you required. Give the parameters like I want the 6 inch width and the 2 inch or the 3 inch height. Right? Once you decide the figures, then again we mention the plots. How many plots you want? So plots comes under the subplots. Again I want the rows and columns. I require the 2 columns and the 1 row. So for the first row, there are 2 columns and at the first positions, I am just splitting the drawing the histogram. So at the first locations or the first column, I'm interested to show the histogram of our data. So here we extract the columns. Whatever column we extracted, that histogram will be shown. Hist. Again, by default, there is a grid lines present in histograms. So it doesn't require the grid lines. So simply we make it false. F is capital, false. Right? Then next subplot, we are putting the box plot up, and box box plot present within the C1 library. So SNS dot box plot, where X is nothing but which data you want to pass on to this box plots. So whatever column is selected from the numeric columns, that will be passed to this box plot. Again, for this box plot, we require some subplot. So plt dot subplot, where at the position row 1, column 2, and the 1 column 2 rows, and the at the position second, we want to put the box plot. Then lastly, we just shown this plot. So this will shows us all the numeric columns plot within this Jupyter notebook, and from this you can easily figure out the peak size. I think so there is invalid syntax, but comma. Okay, one more bracket we have to complete here. Again, one more bracket here. Yes. See, at the first, we are seeing the box histogram, and second, this is the box plots. So histogram showing us the distribution of our feature, and the box plot showing us the outliers present within that feature, right? So this is the year columns, year numeric columns. At looking at this year columns, we are seeing somewhat left skew distribution will be there. It means most of the cars in the years from 2009 to 2009 year is there. So this is the left skew. Then again, majority of the cars from this region only, and the outlier shown here, that is the car year after the, I think so 2003 or 4, it must be discarded from your data sets because it is came in the range of outliers. Then again, kilometer driven, again this is the right skew distributions. Then mileage is the normal distribution plot, and few cars are present, you have to remove that also. Then again, engine capacity is also the left skew, and some of the outliers also present. We have to remove that outliers. Then seat features, it is okay, no issue. Then price, normally the price also the left skew. Most of the cars are of the less prices within the range 1 to 10 lakhs, and most of the cars after that is very less. So outliers also present within this data. Then car age also the left skew, and also the some of the outliers present within this data set, right? So this is the univariate analysis, and in the univariate analysis we have just gone through the each and every features, distributions, their outliers, and accordingly we are filling that, transforming that data. I hope up to now all the things are clear. If anyone have any doubts, then ask me. Vinod sir, am I audible, Vinod sir?
Yes, sir. Yes, sir. Yes.
So,
Yeah.
sir, you are giving me the time 12:40. Is it okay? I'm exit for the 5 minutes so that I can show the heat map
Okay, okay, sir.
multivariate
You take time.
analysis.
Yes, sir, you
Okay,
take
sir.
time because our session is already started 5 minutes late.
Yes, sir. Yes, sir.
Okay, okay.
After the multivariate univariate analysis, gone through the bivariate analysis, and in the bivariate analysis, we're checking for the relationship between the two columns, two features, and on the basis of that, we correlate the features, we remove some features, we add some features, or those who are the features which are correlated, independent features, those who are correlated, then you can remove that features also, and the features correlated between the target variable and the independent variable, that features taken as the important one for the analysis of our further data, right? So for the bivariate analysis, I simply give us the, I'm just skipping that point. I'm just directly go to the multivariate analysis, and I'm just showing the heat map for data set. So multivariate analysis is nothing but at the same time we can interact with all the features present within the data set. These features is relate with every other features, and we just check the linearity between them, or the positive or weak correlations present within that features, right? So we have the heat map. So C1 library heat map of our data sets. Again, this heat map only works with the numeric columns. So we have to select the data type, or the already we have the column we created for the numeric one. We are directly taken the numeric variables, the numeric column from our data set. Either you can select it from the np.numbers, or you can directly pass the number as a variable, no issue, and apply the correlations. Where we have to mention two things here: a not equal to true, and one more is p mean -1, and one more parameter we have to give here, v max. V max equal to 1, and we have to plot this within the matplotlib. So we have to take the one matplotlib figure here, so plt dot figure, and the mention the size of that figure to peak size. Normally I am taking the size of 13 inch width and 17 inch height, and just simply show it plt dot show. I'm checking the code once again so that any column is missing or not. One parameter is missing here. Then okay, all other okay. Then just execute this, and this will show us the distributions of the heat map. Right. So with respect to year and the kilometer driven, there is a negative correlations. We are more interested in price, so checking it with the price. See, this color code system shows us about the, this dark shows the negative correlations. Then again, some fair color shows the again negative up to this point 0. So this comes in the form of color systems. So this faint color showing the positive correlations. So with respect to price, I hope this is the engine is one of the positive correlations. Then again, car age is some of the negative correlations with the help of, and the mileage is also the comes under the negative parts. And this kilometer driven also came in the somewhat neutral levels, right? So at looking at this heat map only, you can check the correlation of every variable with every other variable, and you can easily draw some insights which feature is important one with respect to our target variables. Only that features will be stay in our data sets, and all other remaining features, those who are giving the less information about our data, that will be removed from our data set. So these are the insights we can get through all these exploratory data analysis. So after multivariate analysis, our last step is communicate insights. Whatever insights we get through from the exploratory data analysis, that we have to pass on to our higher authority, higher managers, and basis on that basis can train your AI models so that your AI model will be flourish very well. Okay, thank you everyone.
Thank you, sir, for your valuable hands-on session on the exploratory data analysis or train that AI models. So I would like to ask all the participants, if you have any questions, you can ask now. Okay, I will hand over this to the Komal Lokhande madam. Please give the vote of thanks for this nice session.
Good afternoon to all. On behalf of RIT College, I sincerely thanks our Professor Borate sir for sharing such a valuable insights during today's FDP session. My heartfelt thanks to our principal sir for their constant support and all participants for your active engagement and time. Thank you everyone for making this online session a great success. Thank you everyone.
Okay,
So I
thank you, sir
conclude.
and ma'am.
Okay.
Feedback link will be shared. Feedback link will be shared to the your what FDP group. So all are need to fill that feedback link. So your attendance should be recorded. Okay, next session will be arranged at on the date of 10th of November at sharp 11 a.m. So thank you all the participants and the Rahul Borate sir also on behalf of RIT Polytechnic. Okay, sir.
Okay, sir, thank you.
Okay.
May I leave the session, sir?
Yes, sir. Yes, definitely. Sir.
Okay, sir, thank you.